Hello, welcome to our channel, The Physics Point. And in the previous lectures, we are just discuss some electrodynamics content. And in this lectures, we have started discussion some laws about the electrodynamics. We have discussed the three different laws and two laws of the Faraday's laws. The Michael Faraday, which are discovered the laws, two laws which can be stated to the induced EMF, the relationship between the induced EMF and the magnetic flux. Okay, the first law of the Faraday's. Please take the heading, the Faraday's law. Faraday's laws. The first law of Faraday's is stated that we can consider this is the conductor and we can be supply some current, that is I will be current supply through this conductor. The conductor is AB, or we can be taken one of the coil. Okay, this is our coil bounded of one of this certain metal consider here. Okay, we can be apply the current or supply the current I of that coil. At that time, whenever we can be change the supplied current मध्ये आपण continuously changes करत असाल, wherever we can be change the current, there is a change in the current, the magnetic field is also changes. How can the magnetic field will be produced? If the current conductor is a straight line and the current passing through this straight line, the perpendicular or the surrounding of that conductor, the produce one of the force or one of the field. This field is known as magnetic field. A magnetic field is produced surrounding the conductor whenever the current will be passing through that conductor. Okay, these are the magnetic field. The first law of Faraday's or Faraday's first law is stated that is first law of Faraday's is stated that whenever the changing in magnetic field, how can we change the magnetic field? When we can changes the supplied current of that conductor. त्या कंडक्टर मधून जर करंट चेंज केला तर त्यामध्ये मॅग्नेटिक फील्ड हे चेंज होत असेल. Whenever changing in the magnetic field, okay, whenever the magnetic field or there is a change in, whenever there is a change in the magnetic field, whenever change in magnetic field, that is also B bar here. Okay, they are also called as magnetic field inductions. Whenever there is a change in the magnetic field associated with the coil, firstly we can apply or the supply of some current I to the coil, and just changes or continuously changes these current, then the produced magnetic field is also changes. Whenever the change in magnetic field associated with that coil, an EMF, it means electromotive force. EMF is induced in that coil. EMF is induced in that coils. What happened? This is all about the first law of Faraday's first law. Faraday's first law is stated that whenever there is change in magnetic field, how can change the magnetic field? If we supplied current will be continuously changes. Current change केल्यानंतर magnetic field change होतो. Whenever change in magnetic field associated with the coil, associated one of the considered coil, then an EMF, electromotive force, is induced in that coil. Electromotive force is induced in that coil. This is all about the first law, Faraday's first law. Now discussion the second law, Faraday's second law. The magnitude of induced EMF, तयार झालेला जो काही EMF आहे, the magnitude of induced EMF is the magnitude of induced EMF in that coil is directly proportional to the rate of change of magnetic flux. What is that? The magnitude of induced EMF, the magnitude of induced EMF in that coil is directly proportional to rate of change of magnetic field. Magnetic, not a field, is magnetic flux. Okay, let us consider the phi is the magnetic flux. The phi is the magnetic flux. Phi is the magnetic flux which can be changes, or the magnitude of induced EMF. Induced EMF which is produced, which can be stated by the Faraday's first law. First law means सांगितलं की magnetic EMF, सॉरी मॅग्नेटिक फील्ड चेंज झाल्यानंतर ईएमएफ कसा प्रोड्यूस होतो, तर ते प्रोड्यूस झालेला ईएमएफ ची काउंटिंग केल्यानंतर किंवा मेजरमेंट ऑफ द प्रोड्यूसिंग ईएमएफ और द magnitude of induced EMF in that coil is directly proportional to rate of change of magnetic flux. Let us phi is the magnetic flux which can be produced in that coil, okay, or the magnetic flux associated with that coils. Then d phi by dt is the rate of change of flux. Then the magnitude of induced EMF, that is epsilon, is directly proportional to the rate of change of magnetic flux. Then proportionality constant, that is -1 d phi by dt. This is all about the Faraday's second law. This is the combining of both laws. We get one of the equation, that is epsilon is equal to minus d phi by dt. Then changing in the magnetic field is associated with or is induced some electric field. Then what is the main difference between the electric field and magnetic field? Consider the charges flowing through the conductor in that direction. I will shown on the board using by arrows. Okay, the current flowing through this direction. Then the magnetic field is produced perpendicular to the conductor. The magnetic field is produced perpendicular to the conductor, and they are produced surrounding to that conductor. But the electric field is produced in that direction of the current which are moving. In that directions which the current is moving, then or the electrons or the electric charges will be motions in any directions as that directions which can be produced the electric field. What is the difference? And the electric field and magnetic field are also perpendicular to each other. But the changing in magnetic field, the electric field is also induced. Okay. Then changing in magnetic field, the electric field is induced. What is main difference between the electric field and magnetic field? There are main point is directions. The directions of both electric field as well as magnetic field are different. The electric field is E, or the epsilon is equal to the closed integral of the coil, that is E dot dl bar. Why? That is, the E is electric field associated with the closed integral or line integral of that coils. There are also is equal to minus d phi by dt. Minus d phi by dt. Then there is also using the integrations of both sides, that is E dot closed integral dl is equal to minus integrations of d phi by dt. Minus integrations of d phi by dt. This is the integrated form of, this is integral form of Faraday's laws. This is the integral form of Faraday's laws. Okay. When we can be supply some current I of that conductor, they are produce some magnetic field. If we can be changes the current, we can be changes the supplied current, the magnetic field is also changes. Whenever there is a change in the magnetic field, they are produce some induced EMF or the induced EMF. This is the statement of Faraday's first law. When the produced magnetic or the produced induced EMF, the magnitude of induced EMF is directly proportional to the rate of change of magnetic flux associated with that coil. This is the second law of Faraday's, or Faraday's second law. Then according to the Faraday's second law, epsilon is directly proportional to d phi by dt. We can be taken negative sign for the proportionality constant, that is epsilon is equal to minus d phi by dt. When the changing in the magnetic field, the electric field will be produced or electric field will be induced. Then magnetic field, that is epsilon EMF is equal to phi into E dot dl is equal to minus d phi by dt. E dot dl is the electric field. This can be shows integral of electric field. Then integral of electric field is equal to, we can be used the second Faraday's law, or Faraday's second law. Now discuss the one of smallest law here, that is Ampere's force law. Consider one of the charges Q is moving with certain velocity, moving with a certain velocity v. Then the magnetic field is produced. आपण सांगितलेलं त्या ठिकाणी एखादी चार्जेस फ्लो होत असेल तर म्हणजे करंट फ्लो होणार I is equal to d phi by dq by dt. Rate of flow of charges is the electric current. Electric current is stated that rate of flow of electric charges. This is the definitions and meaning of the electric current. Then the Ampere's force law. Ampere's force law. Okay. Consider a charge Q moving with the velocity v. Okay. Consider a charge Q moving with velocity that is capital V or only V, moving with the velocity v. Then throw a point, then B bar is the magnetic field induction. B bar is the magnetic field induction. Magnetic field inductions. Then the force experienced by that particles or force experienced by the charge Q is equal to, that is the force experienced by the charge, that is Q. The force experienced by the charge Q is equal to F, that is Q into V. There are into then a magnetic field B bar. Q into V bar into magnetic field B bar. The force experienced of that charge Q. A charge Q is moving with the velocity V through a point, and they produce some magnetic field induction, that is B bar, and the force experienced by that particle or that charges Q is equal to F is equal to Q into V cross of B. Then the force experienced the small charge, force experienced the force experienced by a small charge or a small charge, that is dq, or the small force experienced by the charge or small charge dq, they are also moving with the same velocity v and produce the same magnetic field induction b bar. Then df bar is equal to dq into v bar cross of b bar. Okay, and by using these equations, I is equal to dq by dt. Can you understand what I want to do here? पहिल्यांदा आपण काय केलेला, एक चार्ज घेतलेला आहे, ते चार्जला v इतक्या वेलोसिटी लावून मोशन मध्ये आणलेला आहे. If the charge will be motions, they are produce certain or they are experience certain force, and they are produce the magnetic field induction, that is b bar, and the experience force by that charge is q into v bar cross b bar. At that time we can be take one of the smallest charge dq, force experienced by small charge, that is dq is equal to df bar is equal to dq into v cross of b bar. We know that I is equal to dq by dt. If dq is equal to the r, dt is divided with dq, and whenever change their positions and when they are moving with another side of equality sign, then they are multiply with the I, then dq is equal to I into dt, and the value of this dq will be substituted in the equation. This equation is equation, I'll be give the name of that equation is equation number 1. Then df bar is equal to, what is the dq? Dq is equal to I into dt, that is v bar cross of b bar. Okay, v bar cross of b bar. Then we know that the velocity is equal to change in displacement with respect to time, or the velocity or speed is equal to distance, that is the dl, length upon time, that is dt. The velocity is equal to dl upon dt. The substitute the value of velocity in this equation. This is the equation number 2. Okay, this is the equation number 2. Substitute the value of the velocity in the equation number 2. Then the df bar, that is df bar is equal to I into dt into, that is dl by dt into b bar. Then the same sign or the same terms which are numerator and denominator, then they are cancelled. In this equation the same term is dt will cancel, and the remaining equations are df bar is equal to idl into b bar, idl bar into b bar. This is the Ampere's force law. Ampere's force law. कन्सिडर आपण काय केलं, एक चार्ज घेतलेला आहे, त्याला q, we are taken a charge q moving with the velocity v through a point, and they are produce some magnetic field induction, that is a b bar, and the force experienced on the charge q is equal to F is equal to q into v into b. B is the magnetic field induction, v is the velocity of that charge, and q is the charge, and force F be the force experienced by that charges. We can consider one of the small charges, that is dq, and this experience certain force, that is df bar is equal to dq into v cross of b. We know that the definition and equation of the current I is equal to dq by dt. Current, electric current is equal to rate of flow of electric charges, that is dq by dt. Then dq is equal to I into dt. This equation or this value of the dq is the substitute the equation number 1. Then we get off like this equations. Equation number 2. Then we know that the velocity is equal to distance upon time. Okay, or the speed of the object or speed of the particle is equal to distance upon time or length upon time. Length upon time, we can be substitute the value of v in the equation number 2 and we get this equation. The same term which are present numerator and denominator they get cancelled and dt will be cancelled here and df is equal to idl cross b bar. This is the bar. There are also a vector quantity, that is b bar. This is called as the Amperes force law. We have discussed 3 laws in these lectures: the Faraday's first law, Faraday's second law, and Amperes force law. Okay, we are stop here.